All right, this is our last video in section 5.8 on applications of factoring. The last little thing we're going to talk about is Pythagorean theorem. You've probably heard it before, but Pythagorean theorem only applies when we have right triangles. That's a triangle with a 90-degree angle. On a right triangle, you have two legs and you have a hypotenuse. Your hypotenuse is always the one opposite of your right angle. Now, if these angles are labeled A, B, and C, then side A is opposite of angle A, side B is opposite of angle B, and side C is opposite of angle C. You notice that we use capital letters for our angles and lowercase letters for our sides, so make sure you're comfortable with that. If we have a right triangle, then we can say always, always, always that A squared plus B squared always equals C squared. That's the two legs squared added together always equals our hypotenuse squared. So let's see if we can apply this Pythagorean theorem to do one more word problem. Example number 6. It says here, a 50-foot diagonal brace on a bridge connects a support under the road surface at the center of the bridge to a side support on the bridge. Okay, let's read that again. A 50-foot diagonal brace on a bridge connects a support under the road surface at the center of the bridge to a side support on the bridge. So I tried to imagine and draw a little picture. Okay, it's not the best picture, but it's a picture. That we have side supports, and then we have a bridge. That's my red. And then I have some sort of diagonal brace that connects in the center of the bridge to one of the side supports. So that's kind of how I drew my picture. Reading it carefully, visualizing what's happening, really helps me kind of draw a picture and then go from there. So it looks like I'm assuming that these supports are straight and the road is flat. It looks like I have a little right triangle there, right? Okay, and doesn't it say that the brace, the diagonal brace, is 50 feet long? So I can even label that with a 50 foot. All right, let's keep reading. It says here the horizontal distance that it spans is 10 feet longer than the height it reaches at the center of the bridge. Well, height is the distance up and down, and we're not sure what that is. So can I call that x? But then it says that the horizontal distance, left and right, is 10 feet longer than that. Well, if the height is x and I want 10 more than that, could I label that piece x plus 10? And then it asks us to find both distances. So I want to figure out what this vertical distance is and what this horizontal distance is. Now, the only thing I know about this is that I have a right triangle. But I do know that Pythagorean theorem always works when I have a right triangle. I can do a squared plus b squared equals c squared using my labels. So I have an a squared, this side squared, that's a 10 plus x squared, plus b squared, which is my x squared, equals 50 squared. A squared plus b squared equals c squared. All right, it looks a little complicated. We probably want to make this look a little more simplified. Be careful. Please do not distribute this too. Remember, if there's a plus or minus sign connecting my terms inside, I can't just distribute that too. What this means is that I have an x plus 10 twice. I have two of them. So what I really need to do is write it out twice and FOIL. So foiling those two binomials, adding an x squared, and setting it equal to 50 squared, which is 2,500, should look like this. Then I can combine my like terms and subtract the 2,500 over. After combining my like terms, you should have a 2x squared plus 20x minus 2,400 equals 0. Now this looks like a quadratic that I can start to factor. I've moved everybody to the same side and put it in order. I can look for a GCF. Ooh, looks like I can take out a 2. And then I can try to factor my leftover polynomial. This looks like he's a basic factor, so I can find try to find two numbers that multiply to negative 1,200 that add to give me positive 10. You might need to try a few again because our numbers are kind of large, but you should end up getting x plus 40 and x minus 30. They multiply to negative 1,200 but add to give me positive 10. Now that I'm done factoring, I can set each of my factors equal to 0, and I end up getting x equals 40, negative 40, and x equals positive 30. Okay, but what did that mean? What did we label x in the first place? Well, didn't we label x the vertical distance of this bridge? And so if we said x equals negative 40, then that would mean negative 40 feet. It doesn't really make any sense when we're talking about length or distance to have a negative, right? But it does make sense for that distance to be 30 feet, doesn't it? So I can say that that vertical distance is 30 feet. If the vertical distance is 30 feet, well then this horizontal distance should be 10 feet more, or could I say 40? So I can say that my vertical distance is 30 feet and my horizontal distance is 40 feet, making sure that I answer the question and label my answer clearly. Using Pythagorean theorem, a squared plus b squared equals c squared. Anytime I have a right triangle. Make sure that you know it, okay?